Hello, everyone. Thanks for joining and welcome to this session. Let's get started. So my talk is about a software that we developed, Examiner, uh, and how we do deeply randomized assessment with it. So let's go ahead and get started. And I'm going to first tell you a little bit about myself, where I come from, what I do, and how we started getting involved in this kind of work, and how Wolfram Language plays a role into this. So a little bit about me. I'm a faculty at Department of Physics at Indian Institute of Science, Education and Research at Bhopal in India. And I joined IISERB Bhopal in 2012. Before this, I did a postdoc at Carnegie Mellon University from 2009 to 2012. I did my PhD in theoretical high energy physics at MIT. I graduated in class of 2009. I did my Masters of Physics in India at Indian Institute of Technology in Kanpur. These days, my main activities are teaching physics, doing research in physics and mathematics, doing software development, and working in various aspects of education technology. My research mainly deals with the quantum chromodynamics, jet physics, and these days I'm also looking at graph theory and applications of machine learning. Also, in 2015 at IISERB Bhopal, we founded a Center for Research in Advanced Technology for Education and Science, abbreviated it CREATES, and this is where we do our education technology development, and this is where we have developed the software Examiner that I'm going to tell you about. The website of the center is over here, so I would welcome you to check it out at some time, because in this talk I'm not going to tell you much about what we do at the center, but I will just be focusing on one aspect of the center, which is the development of Examiner and how we use Wolfram Language innovatively with the Examiner. So that was a little bit about me. About IISERB, Indian Institute of Science, Education and Research. This is a very new institution. It has only been around for 12 years. It was established in 2008. We have about only 2,000 students. About 600 to 700 of them are PhD students. Rest of them are undergraduates. We have only about 150 faculty members. We have a small campus, rather, only about 80 hectares. We have got UG and grad school in basic sciences, engineering sciences, economics, and data sciences. So as I said, we are a fairly small institution. We are not very diverse. We are very focused. We do a lot of research and a lot of teaching. Recently, we have been ranked 26th among the top 100 young universities. That is the universities and institutions which has come up in last 50 years, according to Nature Index ranking of 2019. Also in India, we are among the top 50 universities, according to the National Indian ranking. Here's a bird's eye view of the campus. So this is our academic block, which is where all the academic activity happens. Now, in my work, I've been using Wolfram technologies in various aspects. I started using Mathematica as a graduate student when I was at MIT, and I've used it extensively during my PhD and postdoc. So I've been, I've been using Mathematica since 2003, and Wolfram Language I've been using for research a lot, and I use it with symbolic computing, data analysis, machine learning, graph theory. So I've my training in PhD and thereafter in research, I've been using Wolfram Language and Mathematica a lot. So that is my background with Mathematica. And since 2012, when I joined IISERB Bhopal, after I came back from US and joined IISERB Bhopal, I've been using Mathematica and Wolfram Language also for teaching. Also recently, we have co-created an undergraduate course called Physics Through Computational Thinking. This is I've done in collaboration with my colleague Aditya Sharma, who is a faculty also at IISERB Bhopal. And we have been extensively using Wolfram Language for teaching computational thinking through this course. We use examples in physics to teach this course. Also, since 2015, I've been using Wolfram Language for education technology development. This is where we have used Wolfram Language to create Examiner, which is an assessment platform for higher education. This is, again, as I said, it's a work done under the center that we established in 2015. So for about last 4.5 years, we've been doing development for Examiner. And this is where, all my background that I had with Mathematica and Wolfram Language doing in research, it inspired me to eventually use it for software development for assessment. And that's what I'm going to tell you about today. So Examiner, before I start talking about Examiner and technical aspects of it, I want to tell you a little story so that you get a perspective of why we started doing this. When I moved back to India in 2012, I started teaching, and I would be teaching a class of 80 students. Pretty much at the time, we were very young institutions, only 5 years old or something, and we had no teaching assistants, and we have to prepare for lectures, present the lectures. After that, we have to give regular assignments and homeworks. Then once the students submit, we didn't have any support for grading, so we would be grading them ourselves. So this is where we started realizing the challenge of teaching in India or higher education academics in India. The challenge we face often is we have a large number of students, very few faculty, pretty much no TAs. Now that we have some graduate students, we are getting some teaching assistants to help us out with teaching activities. But mostly in lots of colleges in India, if you leave the premier institutions, top ranking institutions out, most of the colleges in India, higher education institutions in India, do not have teaching support. In fact, in some of the institutions, some of the faculty have to teach 2 or 3 courses, sometimes even 5 courses. And when they have to teach so much, assessment is something that is often left out. So that's one challenge, that it is expected from us to give regular homeworks. When the students submit the homeworks, we have to grade it. So assessment is a challenge for us to do, and this is where we needed a software or some sort of technological solution which can help us in doing assessment. The second challenge related to assessment that we feel in India is we have large classes, almost no support. So at the end of the day, a lot of students start copying homework from each other, and they don't even realize that what they're doing. And this is something that I realized when I joined here as a faculty and I started teaching, and I realized that I really do not have time to find out whether students are cheating or not, whether they're copying their homeworks from somebody else or not. So how do I test and find out whether they're actually doing work themselves or they're copying from somebody else? So then I started figuring out solutions, thinking about how we can find a technological solution which can help in doing this. And as a first activity, what I started doing is when I realized that some of the students were copying in the exams, and to be honest, I felt that it was not really their fault because they never really understood the importance of homeworks when they were in schools. They did not quite realize. All they had a task that they had to submit the homework to the teacher, and as a consequence, what they were doing was they were just copying the homeworks from somebody and submitting it, and teachers were giving them full score. So they did not even realize what was the importance of doing original work. So when these students come to higher education, suddenly we start to teach them or appreciate them when they start to do original work, or we criticize them when they do not do original work. And moreover, it's a lot of challenge for us to find out who is doing original work and who is not doing original work. So this is where we started facing challenge, and mostly in examinations when we found out that a lot of students were copying from each other. So I really thought, really felt that this was not really a fault of students. We never really gave them an honest opportunity to do some honest work. So one of the things early in the days, what I started doing was because of my familiarity with Mathematica and Wolfram Language, I started generating notebooks in which there will be an individualized question paper for each student, which will be tagged with a number code, and we'll generate the answer key according to that number code. So we'll hand out these question papers to each of the students randomly in the class. So each one will have a distinct question paper generated out of a Mathematica notebook, and they will answer or check mark the questions, multiple choice questions or fill in the blank questions. They will do all of that. They'll submit, we'll use the keys that we have generated to grade that manually. So that worked out very well for me, but I realized that this was something that requires extensive knowledge of working with Wolfram Language, and most of the people were not familiar. Most of my colleagues were not familiar, and if I go outside the institution, a lot of the people outside the institutions were not familiar in other colleges. So then this idea started to develop that if I could create a software platform which could exactly do this, that is, it generates an individualized question paper for each student, testing the same concepts, but everyone gets a different set of questions. So that is deep randomization. So how we generate examinations or assessment for students so that each one of them get a different question paper so that they cannot really copy from each other and they're forced to do honest work by themselves. So this is where Examiner started, and that's why we started building this software. That was what was my inspiration. And initially, in first couple of years, I thought that eventually someone will do it. There are so many software companies. Eventually, someone will come forth and do it. And then after some time, I started really feeling that this is something we need to do. And then fortunately, we got funding support from Ministry of Education. At that time, it was called Ministry of Human Resource Development. And that with that funding, we established the center and we started doing this software development. So here's my reason of choosing Wolfram Language for developing Examiner. Wolfram Language is a complete package for mathematics and computation. Everyone here is familiar with Wolfram Language, so I don't have to describe that. One of the beautiful things about Wolfram Language is that there's an automated interpretation of mathematical expressions. There are functions which are interpreted mathematically and they're computed mathematically. I can do symbolic computation, I can do numerical calculations, and even I can, once I've done the numerical calculation or once I've done the symbolic computation, I can go ahead and output that as a TeX or MathML output. Both of these outputs are suitable for web applications. So Wolfram Language is providing me a complete package for deep randomization for assessment, and we have already done that through the notebooks. Now, what we wanted to do was we wanted to translate that from notebooks to, and then convert them into PDFs to directly to put it in the web so that these deep randomized assessment content can be delivered to the students through web technologies. They answer the questions on the web, it gets graded automatically, they get the immediate feedback so that when they get the immediate feedback after doing their quiz, what they have done is fresh in their minds. So they want to learn from it. They'll go back and check. They'll find out their mistakes. They'll come and discuss with teachers. Usually when we are doing a paper-based test, we get it back, we grade it, we give it back, and it usually takes a long time. It sometimes takes several weeks. And when that happens, they've forgotten what they did at the time in the test or in the homework. And in that process, they have lost the, they've lost the desire to learn because they've already forgotten what they did. So immediate feedback is very, very useful. And this is where we thought that, doing this through a web technology and automatic grading will really be useful. So that's where Wolfram Language comes in. And I'll give you some idea of how we're using Wolfram Language to do this. So what is multi-layer deep randomization? So there are few different layers of randomization that pretty much any assessment platform, especially after this COVID-19 era, all the teachers, we have started using some sort of LMS or some sort of assessment software for conducting online quizzes, even if it is just Google Forms. Now, so when there's certain randomization that is available in pretty much in all these platforms, whether it's Moodle, whether it's Blackboard, whether it's Canvas, and some of these basic randomization techniques are randomize the question selection. So if I give you 20 questions and you can select 10 randomly for each student and deliver to them so that everyone gets a different set of 10 questions. That's one way of randomization. Another way of randomization, you randomize the order of questions so that they cannot compare at which number I've gotten a certain question, which number they've gotten a certain question. So it makes it a little difficult for them to find out and tally with each other, especially when you have no invigilation at all. The third way of randomization is selecting the items or randomizing the order of the options. Again, this is something that is available in all platforms. So where Examiner stands apart from all of them is deep randomization, where we do deep randomization of content through parameterization and computable mathematics. What that means is that everyone is delivered the same question where they, the same concept is being tested, but we change the content internally. Some of the numbers are changed, some of the numbers are randomized, some of the functions can be randomized, images can be randomized. So the kind of randomization we can do with computable mathematics and Wolfram Language capabilities is that we are able to do arbitrary parameterization and arbitrary deep randomization. So it's not just limited to numbers, it can be expressions, it can be images, all of those things. So this is how we actually implement Wolfram Language. We have created a computable math language called Mingo, which is the language for frontend. And in some sense, it's inspired a lot by Wolfram Language, TeX, and ASCII Math. These are some of the languages for mathematics. Now ASCII math is just representation of math. TeX is representation of math. It's narrative mathematics. So both TeX and ASCII math are narrative mathematics. Wolfram language is something that is both computable and can also be used for narrative maths. So we designed a much lighter version of such a language, a computable language called Mingo, which is compiled in the backend and evaluated by Wolfram language compiler. And it is it is evaluated and computed to give a properly typeset MathML output, which is what is rendered on the web browser. So I'll give you a demonstration of that in a moment. Now, what authors do is, authors means the teachers. We give accounts to the teachers. Teachers create on the front end. They create the content with narrative text and Mingo to create assessment content. Mingo is a computable language. So if they put in a formula, that gets computed. Now, authors, when they typeset expressions in Mingo, they also set some parameters. These parameters can be numbers. These parameters can be expressions, and these are images, even functions, and they're substituted into Mingo expressions during the evaluation. And these substitutions are random. So every time unique content is generated for a user, and this is what we call as deep randomization. In the backend, we have Wolfram language and Web Mathematica, which is used to compile and create assessment content and quizzes. Wolfram language we also use for grading quizzes. So this is the component of the Wolfram language in the background. And I'm now going to show you a demonstration. So let me just quickly go to the browser here. So here's a quiz that I've recently taken for my participants. This is the quiz management page, which shows how much progress they have made, when did they submit, how much score they got. So this is live updated, but that is not that doesn't involve Wolfram technology. So here's a student's quiz. So this is where you see this is a quiz that a student has taken, and this is an arrangement question where some space-time points are given and they have to arrange them in the order of I believe this is in the chronological order of occurrence in a certain relativistic frame. And similarly, so this is an arrangement question. Here is an example of a fill in the blank question, and you see there is a value here which is random for each student. There's a value here that is random for each student, and as a consequence, this answer that they have to calculate is random for each student. And also, you can see the class statistics, and student can compare how he has done. He has worked in comparison to the class. Again, here's another fill in the blank question. Here's a multiple choice question, and you see there are some numbers here which get randomized. We can set those numbers, and let me show you an example here. So I think this is a question. So this is a question. So you see this is a fill in the blank question. I can give some instruction, and this is where my question is, and this is where computable math goes. So this is Mingo. This is computable math goes in this mode. So it's much like LaTeX. You can write narrative text, and then you can write some computable maths in Mingo, and then this is compiled in a Wolfram language compiler in the backend. And after that, the content is generated. And if I do a give 5, and I also set up the answer key. An answer key is some sort of computation which is defined in terms of this variable called answer. And this answer is defined over here. It's calculated in terms of parameters A and B, and the parameters A and B are defined over here as various things. So this A can be any of these values. So any one of these values will be chosen randomly, and B is any one of these values chosen randomly. I can also correlate A and B. So when a certain value of A is chosen, I can choose certain value of B, and so on. So if I do a give 5 over here, I'll generate 5 random instances of this question. So in this particular instance, A is 1 by 4 and B is 1 by 4, and I get this question, and correspondingly the answer has a certain range. And I see, this is the second instance. Again, the parameters has changed, and correspondingly the question and the answer has changed. And over here, another set of parameters, and the question has changed, the answer range has changed. So this is how it works. And I can define parameter as lists, ranges, or I can correlate them using a set of group parameters. So all of those things are possible. I can also define some definitions and include those definitions in the part of the question or part of the answer. So this was fill in the blank question. Here's an example of a multiple choice question. Again, there are a bunch of parameters that are defined over here. And let me show you one more. So here, this is the authoring portal. This is where people create content, that is teachers create content. Here's an example of a arrangement question where some items are given. They have a value that is evaluated automatically with a formula. So for example, over here, this is my statement of the item, and these are the corresponding values. Okay, I see there are some questions. So let me just wrap this up and then I'll look at the questions. So this is how I can program for each of these items. What is the value that is going to evaluate to, and when the students arrange these items, the system automatically checks and whether the values are arranged in the increasing order or decreasing order, and you select the order from here. And if they're properly arranged in the increasing order or decreasing order, they're automatically graded as correct or incorrect. So let me come back to, so that was a quick demo, and I see there are a couple of questions. Let me just look at those questions. How students access this platform? Is it integrated with something as a LMS at your university? So this is accessible at this site called examiner.in. So if I just open a browser and just type examiner.in, it loads up the login page for students, and there are two tabs here. There's a student tab and an author tab, and authors can request an account. Students don't need accounts. When a quiz is created by the authors, their accounts are generated automatically, so they don't need any accounts. And this is where teachers can log in and access the platform. This is what the platform looks like. This is my dashboard, and I do create content, various kinds of content I can create from here, and I can create a library of committed content, and this library of committed content I can pick and choose what I want to use in my next quiz and so on. So that was a quick demo. I don't have time to show all the features in detail, but I just wanted to give you an idea of how we're using Wolfram Language. So now I'll just quickly go over in next few minutes features of Examiner. So in Examiner, we have got 4 or 5 different kinds of assessment contents. We have multiple choice questions, arrangement and order items, fill in the blanks, and we have got subjective questions and with assisted grading, which is something we're still working on. And all these questions can contain any kind of media. We can have vector images, embed anywhere in the question. You can have it in the question, you can have it in the options. So whether it's a vector, whether it's a bitmap image, whether it's a video, whether it's a PDF file, whether it's a data chart, all of these can be embedded anywhere in the content, whether it's informational content or the assessment content. So there are a couple more questions. Let me take those questions. I'm seeing some questions on Pathable. What is the student interface like? Is there a palette where they can insert maths without knowledge of Wolfram language? Yes, students don't need to know Wolfram language. In subjective questions, they can actually insert maths using LaTeX or ASCII math. And the student interface actually just looks like this. So this is the student interface. Actually, this is a particular student who has already taken this quiz, and I'm showing you after the quiz what it looks like. During the quiz, they were able to select one of these MCQ options, or they were able to fill the blank in during the quiz, and after the quiz, this is what it looks like. There's one more question by Milana. Are there any plans to use this assessment platform in other institutions? Is there any website with examples and documentation? So we are using across multiple higher education institutions in India. We have not really launched it outside India, but we can do it for a few people who are interested in trying it out. Right now, we are just giving accounts to faculty in India, and it's really easy to sign up. If you go to the examiner.in, click on the author tab, and if you request for an account, you can fill out this little form and we can provide accounts for you. Again, this will be like in the trial mode for outside India. So we are not really promoting right now outside India, but eventually we'll start working with institutions out of India also. Is there a website with documentation? Yes. If we go back to this page, there is a little link here, read the docs. And the docs, we have given detailed documentation of how to work with the platform. There are also video tutorials to learn how to create content, and also a detailed documentation about how to use Mingo. That is the language that we have created. So coming back to, back to languages, I think I have just about 3 minutes. So coming back to languages, we have support for all the languages. It's whether it's English or Spanish or French. Any of the languages which are supported by Unicode standard are supported. That is, in simple words, anything that is supported by Google Keyboard is also supported on Examiner. We can do equation typesetting using TeX and ASCII math, which are just narrative mathematics, and also with Mingo, which is powered by Wolfram Language in the background, and this is computable mathematics. We can do some kind of content markup through HTML tags. Our tech stack is actually very modern and scalable. We use AngularJS and Bootstrap in the front end. Nginx works as our web server, proxy server, and load balancer. We use Node.js for backend services, web services, and the backend is powered by Wolfram Language, which is where we do all the intelligent things. That is, we compile the content over there. We generate the quizzes which are deeply randomized, and our database is NoSQL database. So the Node.js and Wolfram Language talk to each other, and then we have got Node.js and CouchDB talk to each other, Wolfram Language and CouchDB talk to each other, and Nginx works as a proxy server for Node.js, and it delivers the services to the front end. So that's our tech stack. We have got synchronous quizzes, which is live quizzes. You can push same content to all the students simultaneously. You can also push a live stream through YouTube Live. There are certain constraints that YouTube Live applies. If those constraints are not there, then you can push that content. You can include a chat or whiteboard. You can see the live statistics of the class. And you see here, this is the live statistics of the class. You can see, statistics of the class. You can also share the statistics with the class. You can also tell them whether they've answered the question correctly or not. So this is really great for formative assessment. And then we have asynchronous quizzes and lessons, which are really great for summative assessment. You can embed a video anywhere. So here's an example of informational content where a video is embedded and also a PDF file is embedded, so that students can watch the video, refer to the PDF file, and then follow up. They can work on some questions based on those videos. So this is the lesson mode. Then you can have testing. I've already shown you some examples of that. You can provide elaborate instructions. You can design a flexible grading matrix. You can do detailed performance, summary, and analytics. Also, we have got detailed quiz management features where we have got detailed quiz properties, control quiz sessions, live tracking of student activities. You can collaborate with other teachers in creating quizzes. You can distribute passwords either through emails or on paper. You can download performance summary report, and all of these features actually provide you detailed control over the class, and therefore you can do a crisis management very efficiently. So as I've mentioned, Wolfram Language, it's really, the core of it. It's the soul of the system. It powers Mingo, the computable math language that we use. It powers deep randomization. It generates individualized quizzes and also grades quizzes for students. This is where the Wolfram Language comes in. And Examiner, so far, we've only released it in India. We have 850 authors, 7,000 contents created, 1,300 quizzes. We have 38,000 quiz users, out of which 10,000 are unique quiz users, and 64,000 quiz sections have been delivered. So a summary and looking ahead, without Wolfram Language and without experience with Wolfram Language and without its capabilities, we could not have comprehend Examiner, and we would have not thought of doing deeply randomized assessments in the way we are doing it. In the future, we want to build adaptive testing using item response theory, use AI to evaluate subjective content, and reach out to wider user base globally. Finally, this is my team. So most of these people are developers. They work on various web technologies. Some of them are managers, project managers, which do various kind of management tasks. And in this team is also this lady who's my wife, and she has done a lot of beta testing for us on Examiner. She's a math teacher, and she has used all her math skills to test various kinds of things. So finally, I would wrap up my talk by acknowledging the Wolfram Technology Conference team for giving me an opportunity to present here. I also give special thanks to Abel, who introduced me to Wolfram Technology Conference. And finally, I thank Ministry of Human Resource Development of Government of India, under the National Mission on Teachers and Teaching, supported the funding for this particular event. And I thank my institution, IISERB Bhopal, for hosting this application. So thank you for joining me today. And if there are any more questions, I'll be very, very happy to take them. I think there was a follow-up question. What courses are using Examiner now? So we use it for pretty much everything. So I have used it for physics. Some of my colleagues have used it for mathematics and chemistry. And then even English teachers have used it. And in other institutions, I have no idea, but definitely there are engineering faculty who are using it. There are humanities faculty who are using it. There are biology faculty who are using it. So all kinds of people from all spectrum are using Examiner right now. Thanks, Matt, for your comment. Thanks, everyone. And once more, Abel, thanks a lot for bringing me here to Wolfram Technology Conference. I see you are one of the attendees. So once again, thanks a lot.